Hi, everybody. Welcome back. Today's lab is qualitative analysis. What is qualitative analysis? Well, going back to the definition of chemistry, chemistry is the study of matter. It's the study of the properties of matter, the changes that matter goes through, and the energies that are involved in that exchange, right? So the number one thing of studying chemistry is studying matter. And matter is just a fancy word for stuff. Like everything that we see around us, including us, is what matter is. So we study the properties of matter. We have to measure them, right? So you can measure, for example, right? You can measure this chemical, right? You can measure the mass of this phone, for example, or you can just see the quality, right? You can look at the color, for example. You can look at something like, is it there or is it not there? So, qualitative analysis just has to do with the quality. And then, quantitative analysis is when we get to measure and see how much something weighs, what's the temperature, and so on and so forth. So, qualitative analysis is very important in chemistry. So today's lab is going to look at qualitative analysis. And qualitative analysis is when we're studying a description of something and it doesn't involve numbers or units of measurements, right? So it might be something like color, solubility. Is it something hot or cold? That's quality, right? But when you start measuring the temperature, that is quantity. So qualitative versus quantitative, right? So one of the biggest things that we're going to look at is color. We're going to look at different colors. And as you can imagine, different chemicals have different colors, different ions dissolved in solution have different colors, right? So there is this rule that we call the rule of solubility. And you probably have seen this, I'm pretty sure. But some chemicals, when dissolved in water, when put in water, they don't dissolve in water, right? So, for example, compounds containing lithium, potassium, sodium, rubidium, cesium, these are all soluble, right? If you have a nitrate, bicarbonate, these are all soluble as well, right? But sometimes if you have like um, a halide, a halogen, like Ag, right? If you have like a halogen like chlorine, bromine, and iodine bound to a metal like Ag, which is silver, or Hg, which is mercury, or Pb, which is lead, these will be insoluble, right? These are the rules of solubility. Um, and so if you have like AgCl in a solution, it will not dissolve. A it will not be liquid. It will be cloudy. It will be a chunk in a solution. That's what we call a precipitate, right? Other compounds that are completely insoluble are things like carbonates, right? Phosphates, chromates, sulfides, except when you have something like sodium or ammonium, right? And hydroxides are also insoluble, except when you have, again, alkali metal ions like sodium, potassium, lithium, and so on and so forth. So, as you can imagine, these are rules of solubility. And these rules can tell us, they can give us an idea of what is in a solution. This is another way to kind of show you. This is another way to express the rules of solubility so that you can remember them. But we use this, for example, we can use solubility rules, right, to determine the presence of a certain ion. That's the whole point of qualitative analysis, right? So if you mix, for example, a certain, you want to see if you have, like, I don't know, silver, right? If you want to know if you have silver or mercury or lead, you can add a halogen and be like, oh, okay, I have a halogen. If I see a precipitate, you're like, okay, I have one of these three. So that's one way you can detect the presence or absence of a certain ion by precipitation, right? So an example is, for example, you get a water sample and it has acetate in it. How are we going to detect acetate? Well, there are rules that tell us that if you add silver or mercury to acetate, there will be a precipitate, right? So you can use that. Now, one of the biggest problems when it comes to these is that it's not, as you can see, it's not just uh like mercury that can precipitate. For example, if you want to separate mercury and silver, you won't be able to do that because they all precipitate acetate or something like that. So we're going to, most of the time in nature, have a mixture, right? We're going to have a mixture. So most solutions will contain more than one type of ions, right? So instead of just finding one qualitative analysis, you do a series of qualitative analysis experiments, right? So you're going to be like, oh, okay, let me add HCl, for example. Why do we want to add HCl? Because we already saw from these rules that chlorine will precipitate these, right? These groups and leave the others alone, right? For example, it will leave these alone. So if we want to separate cations, what are cations? Do you remember what cations are? These are positive ions, right? So these are metals. So if we want, you have like a mixture of a bunch of unknown metal ions, right? The first thing you do is you add HCl so that you can see the ones that get precipitated by chlorine. So this will be silver, lead, and mercury. Oh, okay. That we call this group one. And then you can add H2S. Why? Because we know that these group 2 ions precipitate when they're bound to S, right? And then after that, you do more tests. So this is a series that we do so that we can tell exactly what we have in a mixture. So this is what we usually do in a lab. But what we're doing today is a like it's a condensed version of it. So what are we going to be doing in the lab? We are going to be looking at 4 different qualitative tests, 4 different tests, right? And 2 of them will be for cations or positive ions, and then 2 of them will be for anions or negative ions. So I'm going to give you a bunch of solutions, and you're going to have to tell me, I will give you known solutions and then an unknown solution to tell me what's in there. So we're going to start with an NaOH test. So you're going to take the three solutions, right? Calcium, copper, and iron, and then you're going to add NaOH. Why? Because they have different, distinct precipitates. This lab should be pretty colorful. So we're going to have calcium hydroxide is white, copper hydroxide is going to be blue, and then iron should be brown. Okay, so these are going to be colorful experiments, but they are dangerous. So make sure that you wear your gloves, your goggles, make sure that you're protected. Right? So from NaOH test, we're going to do NH3 test. That's ammonia, right? So ammonia also is going to bind to calcium, copper, and iron, and we're going to look at different observations, different colors, and these colors are going to be different from NaOH. By the way, again, on top of testing these 4, you're also going to be testing the unknown that I'm going to give you, right? So you're going to test these four and then unknown. For NH3 test, you're going to test these and unknown as well. So you're going to test copper, iron, and calcium, and your unknown. And then you're going to compare. You're going to be like, oh, okay, based on this observation, is any of these in my unknown? And then from there, you're going to look at HCl test. In this HCl test, we're going to be testing our anions. Why? Because if you add carbonate, right, to a certain anion, you can actually make what we call effervescence, or we're going to produce bubbles, which is gas. So in a chemical, right? So in a qualitative analysis, one of the observations is formation of precipitate. Another observation is the change of color. And then another observation that we're going to be seeing is the production of bubbles, right? Bubbling, which is production of gas. So here you should be able to see it if something has a carbonate. So if something has a carbonate and then you add HCl, it should give you CO2, right? So this is an anion. And then here, we also going to do what we call silver nitrate test. Why? Because silver nitrate, right? If you add, it's used to check if you have like chlorine, for example, or iodine. Because if you add silver nitrate to chlorine, it's going to give you a white precipitate, right? So this is kind of a nice table talking about everything that you're going to be doing. Don't worry about the observation. You should write down your own observation, but we're going to do NaOH test, right, on your calcium, but calcium, iron, calcium, copper, iron, and unknown, right? And again, don't worry about this observation. You're going to write down your own observations, right? NH3 ammonia, same thing. We're going to use copper, iron, calcium, and unknown, right? And then for HCl and AgNO3, you're going to be measuring your chlorine and carbonate and unknown, right? So we're going to have to kind of put it all together. Let me see if I can do this, right? To kind of put it all together, you are going to have 4 tests. So 4 tests, all qualitative, right? And then you're going to be, the first one is NaOH, which will be 4 samples. The second one is ammonia, NH3, also 4 samples. And then the third is going to be, I think it's the CO2, the carbonate one. So it's going to be HCl. It's going to be 3 samples. And then we're going to add silver nitrate, 3 samples, right? So in these, again, we're going to have, for the 4 samples, is going to be 3 cations and 1 unknown. 3 cations, 1 unknown. And then for the 3 samples, it will be 2 anions and 1 unknown. And what I want you to do, by the way, by the end, I will just tell you this. In your unknown, I have put a cation and anion, right? So your unknown has a cation and anion, and you have to tell me by the end of this lab which of these that we have in our solution. All right. So this lab should be easy, should be fun, but make sure that you are well protected because some of these chemicals are nasty. But without further ado, let's get started. Since we're working with dangerous chemicals in today's lab, you're going to start by putting on your gloves and goggles. You should have gotten gloves in your kit, but if they don't fit you, make sure that you get some gloves from Walmart or any other store. Some normal nitrile gloves should work. And after putting on your gloves, you should put on your goggles. You should also have some goggles in your chemistry lab kit. And after you get started, make sure that you have what you need for today's lab. For today's lab, you're gonna need test tubes. You should also have solutions that are needed for today's lab. There are 6 solutions that we are testing, and then the 4 testing solutions as well. Your manual should list all of the chemicals needed. You also need a test tube rack and some test tubes. You will start by assembling the test tube rack as shown in the video. And as you can see, it should be easy to assemble and put together, and you should be able to, after assembling it, use it for the remainder of the lab. So make sure that they snap together, they all go together the way they're supposed to go. It might take a little bit of moving around, but after a while you should be able to put it all together. Now you are ready to label your tubes. So just like the procedure shows, you're going to test 6 chemicals. But in order to test 6 chemicals, you're going to start by testing your cations. We do have 3 cations to test. You're going to test your cations, 3 plus the unknown. So you have 4 cations. And in order to test the cations, as we discussed, we're going to test them by using ammonia and NaOH. So the way to do it is you're just going to add some drops into your solution. And as the procedure calls, your samples will get about 1 ml into the test tube. That's about 20 to 25 drops. And you're going to add about 5 drops of your solution. Remember, this is a qualitative lab. We don't care too much about the quantity, we care about whether or not something is there. It's not a quantitative lab. So as long as you see a change, you should be good. So you're going to drop your solution into the test tube as shown in the video, and then you are going to record your observations. Right, so whenever you see a precipitate, whenever you see a change of color, whenever you see bubbles, you are going to record all your observations. And after you record your observations, you're gonna go to the next one, and then you're gonna keep going until you finish all of your cations. You're then going to move into the next section, which is your anions. So you're going to actually do the second test, which is the NaOH. So you're both going to do NaOH and ammonia for the cations, 3 cations and an unknown. And then after that, again, observations, recording your observations. And then after that, you're going to move to the next section, which is going to be the anions, right? Notice that we are looking at the changes, recording the changes, making sure that we record our data, because the data will be our observations. And after that, again, we are going to move to the next section, and we are going to keep making observations until we done. During the anions, make sure that you look closely at the observations, because not only are we going to get a change of color or a precipitate, but in some of the tests we should all see some bubbles or formation of gas. And for each one of the tests, make sure that you use the unknown as well. So we're going to test three cations and two anions, but for each test, we're also going to have an unknown. So that's what we're doing here, and that's what we're testing here. And again, after you do all of the tests, what are we going to do? We are going to record our observations, and then we're going to put all our solutions into a waste beaker. So that is a waste beaker that we're going to be using, and you should have gotten it. You're going to pour everything in there. We're not going to pour it into the sink. We're going to pour it all in there, and you're going to return this. We're actually going to use this waste beaker for another lab as well. So make sure that you keep it, make sure that you seal it well, and make sure, as always, that you are staying safe. You're wearing your goggles, your gloves, you're working in well ventilated environment, and you are not touching any chemicals, you are not testing them, you are not spilling them, and you are not using anything that will put you in any danger. Safety is number one when it comes to lab experiment before anything else. But after you have gotten rid of all of the waste, make sure that you wash your test tubes. Wash your test tubes. You can wash them in the sink now. You can close them. You can put them back in your box, or just keep them drying on your rack. And after that, you should be good to go. You should be ready to go back to your computer and finish up your lab. Okay, that was qualitative analysis. I hope you have enjoyed it. It's a fun lab, but it can be very tedious. But I hope you have been able to identify which anion and cation are in your unknown. Make sure that you have filled in your data table, the pre-lab, the post-lab. Make sure that you have answered all of the questions. And as usual, if you have any questions, feel free to reach out. And other than that, I will see you in the next lab. Bye bye.